These days, you can be almost anywhere on Earth and have access to the internet. We're able to get that access thanks to satellite networking, where we are communicating from Earth to a satellite and back down to Earth again. Since we are launching a satellite into space to provide this type of connectivity, the relative cost of satellite networking is a bit more expensive than something that you might use terrestrially. But that additional cost does provide a very functional connection. It's very common to see 100 megabits down and 5 megabits up when you're using a satellite network connection. This is perfect for remote sites and places where it may not be possible to get a traditional form of internet connectivity. One of the challenges we've traditionally had from satellite networking is that we have to send this signal so far into space and back down to Earth again that it adds additional latency to the connection. Traditionally, we've seen systems have about a quarter of a second up and a quarter of a second down, so there's about half a second latency just to be able to send packets up to the satellite and back down again. The newer Starlink connections are a little closer to Earth, and therefore the latency numbers are a bit smaller. Starlink advertises around 25 to 60 milliseconds of latency, but even they're working to bring those numbers even lower. Satellite networking isn't without its faults, of course. We have the concern of being able to see the satellite, so our connection between us and that satellite needs to be a line of sight. We might also have connectivity problems if a large storm comes through. We refer to that type of connectivity issue as rain fade. One of the fastest ways to communicate is using light itself through fiber optics. This allows us to send a lot of data through a very small fiber, making for one of the most efficient ways to transmit large amounts of data. Compared to copper, fiber is a bit more expensive, not only for the fiber itself, but for the equipment that connects to the fiber. And if you need to repair the fiber, those costs will be a bit more expensive than having to repair something that is copper-based. But fiber does provide us with a way to not only transmit large amounts of data, we can do it over distances that are much longer than we can with copper connectivity. And since we can put so much data over a single pair of fiber, it's a perfect connectivity over long distances for your wide area networks. So inside of a metropolitan area or connecting multiple metropolitan areas to each other, it's very common to see a sonnet ring or some type of multi-wavelength fiber connection being used to transmit data from one place to another. It used to be that fiber was exclusive to these very large wide area networks or inside of a large corporate core. But these days, fiber can come directly to our home, and it's not unusual to see a conversion outside of our home to convert from the fiber on the street into the copper that we use inside of our house. One of the most common copper connections for internet connectivity is the cable that you would commonly associate with a cable television. We're also able to run data over that connection, so it's not unusual to plug that into a cable modem and be able to access the network through the Ethernet connectivity that you would normally have inside of your home. This cable provided by the cable company has a lot of different frequencies running on it simultaneously. We refer to that type of technology as broadband. We can run different frequencies with different traffic types all at the same time over the same wire. This allows us to run many different frequencies using different services over the same copper wire, and it makes for a very efficient way to provide voice, video, and data for an entire home. The standard used for sending data over these networks is referred to as DOCSIS. This is the Data Over Cable Service Interface Specification. There are different DOCSIS versions that provide different levels of service and different speeds of connectivity. On many of these cable networks, you'll find internet connectivity speeds will range between 50 megabits per second all the way up to 1 gigabit per second and even higher. This provides us with extensive data connectivity to the internet, and since we are bringing this in from the cable company, we can also have television and voice communication over that same wire. Many homes also have telephone service that's provided by your local phone carrier. That phone company can also add digital data onto that same connection that's used for voice communication. We refer to this as DSL, or digital subscriber line. You'll sometimes also hear this referred to as an asymmetric digital subscriber line, or ADSL. The reason we refer to this as asymmetric is that the download speed is often much faster than the upload speed. For example, it's not unusual to find DSL connections that may have a 200 megabit per second downstream speed, but a 20 megabit per second upstream speed. Not only do we have this difference in speed, but there's also differences depending on how far away we might be from the central office. The farther away you are from the central office, the slower these speeds will be. And DSL tends to require that you're about 10,000 feet or closer to a central office. Our cellular networks also provide us with internet connectivity. This technology uses the same infrastructure as the one we use for our mobile phones, where we're separating a geography into smaller cells and connecting them together with antennas. Some folks might use the mobile phone as a jumping off point, where they will connect their device to the mobile phone, and the mobile phone then provides connectivity to the internet. This one-to-one connection is often referred to as tethering. If you have a phone that provides internet access for multiple people simultaneously, then you're using your phone as a mobile hotspot. You may want to check with your mobile carrier and see if you can get internet connectivity through tethering or a mobile hotspot, and they might also be able to tell you if there's an additional cost for that service. In some areas, it might be difficult to get a copper cable from your cable company or even a phone line from your local telephone company. In those situations, you might want to use a wireless connection to an internet service provider or a WISP. This is perfect for remote locations where you wouldn't normally have a connection from any other type of internet provider. This is also very simple to set up because all you really need is an antenna and you're now connected to the WISP network. On the wireless network itself, you may be using a number of different technologies. It might be a meshed 802.11 network, which is the same kind of 802.11 network that we use in our homes and businesses. This might be a 5G home internet connection where we're using a traditional mobile phone provider as our internet service provider. And we could even be using some other type of proprietary wireless connection. To be able to access the wireless internet service provider's network, we need an antenna outside, and that usually will give us speeds that range anywhere from 10 to 1,000 megabits per second.